Previous videos on trigonometry looked at right-angled triangles and the relationship between the angle in a triangle and the ratio of a pair of sides. For a given ratio, like opposite over hypotenuse, the sine ratio, it doesn't matter how large you make the triangle, so you can enlarge or reduce the triangle, it won't change the value of the ratio opposite to hypotenuse. For example, if you doubled opposite, it would double hypotenuse as you enlarge the triangle, and that would cancel out to give you the original opposite over hypotenuse ratio. So the over h ratio can't change just by enlarging and reducing the triangle. You can only change the ratio's value if you change the angle. When we're graphing the sine function, we used a hypotenuse of 1 unit long, so it was scaled down to be 1 unit. The advantage of this is when you get the ratio opposite over hypotenuse, it's opposite over 1, and that means the length of the opposite side is also the value of the sine ratio. We're going to do this here as well. If I divide all the sides by the length of the hypotenuse h, I'm scaling down the triangle. It won't change the value of the ratios, but it will make the hypotenuse 1, and this opposite side becomes over h, which is sine a. In other words, the length of this side is the sine of the angle, and it will make this side here, the adjacent over hypotenuse, will become cos a. So that's the sides are now sine a, cos a, and 1. So if you're looking for sine a, it's equal to sine a over 1. The opposite side is sine a. If you're looking for cos a is adjacent over hypotenuse, cos a over 1. So the adjacent is cos a. That's also the value of the cosine of the angle. If you're looking at tan a, which is opposite over adjacent, tan a is sine a over cos a. And that gives us our first identity. Tan a in this triangle with a 1 unit long hypotenuse is sine a over cos a. That's called a trig identity because it doesn't matter what you put in for the angles. This will always work. If I had sine 30 degrees over cos 30 degrees, the answer that gives will be the same as tan 30 degrees would give. If I had sine 200 degrees and divide it by cos 200 degrees, I would get the same value as tan 200 degrees would give. So it wouldn't matter what you put in for the angle A, this will always work. That's an identity. If we apply Pythagoras' theorem to this triangle, the two shorter sides squared and added will make the hypotenuse squared. In other words, sine a, if you square it and square cos a and add them together, it will give you 1 squared. That's Pythagoras. 1 squared of course is 1, and we usually write sine a all squared is just sine squared a for short form. It does mean sine a gets squared, cos a gets squared, but it saves us writing the brackets all the time. That also is a trig identity. It doesn't matter what you put in for a. If I put in 200 degrees for a, I get sine 200 degrees and square it, cos 200 degrees and square it, add them together and it will be 1. You can do it in a calculator and you'll see it works. What I've done here to show it works is I've taken the triangle for exact values. I'm going to use 30 degrees and get a replaced by 30 degrees. So this will become sine 30 degrees and square it, cos 30 degrees and square it. So remember, that's what sine squared a means. It means take sine a and square it. Sine 30 from the triangle is over h, 1 over 2. It's a half. Cos 30 is a over h. That's root 3 over 2. And each of them has been squared. A half times a half is a quarter. Square root 3 over 2, you're squaring root 3 and you're squaring 2. Square root 3 and you'll get 3. So it's now a quarter plus 3 quarters, which is 1. So it wouldn't matter what the angles were here. This would always work. It comes out at 1. So that's that identity. Tan a here, sine over cos a, will take sine a over cos a and I'll make it sine 30 over cos 30. So this should come out at the same value as tan 30. So as we got in the triangle, sine 30 was a half and cos 30 was root 3 over 2. To get rid of the fractions here in the top, I can double the top and double the bottom. double the top, you get 1, double the bottom, the 2 in the bottom here, the fraction will cancel out, and it'll give you root 3. So that's 1 for the top, root 3 for the bottom. Well, if you look at the triangle, 1 over root 3, that's opposite over adjacent. Tan 30 is 1 over root 3. So that's tan 30. That's also 1 over root 3. So it shows this identity working. Sin 30 over cos 30 is tan 30. Now, we usually use them to simplify trig expressions or trig proofs, which means an equation where you show the left hand side equals the right hand side. So we use tan A equals sine over cos A, and we also use sine squared A plus cos squared A equals 1. But this can be rearranged. I could take the cos squared A onto the right hand side, and I would get sine squared A is equal to 1 minus cos squared A. So it's just this rearranged. Could have taken the sine squared A to the other side, and I would have got cos squared A equals 1 minus sine squared A. So they can be used as well. It's just this form rearranged. So these 4 things you now see get used in proofs. So here's simplify cos A times tan A. You see a tan A, all you can do really is replace it with sine over cos. There's not much else to do. So there's tan A replaced with sine over cos, and then you'll maybe spot that the cos A in the top will cancel with the top cos A in the bottom, and it will come sine A. So that's been simplified using one of the identities. Here's another one, 1 minus cos squared over 1 minus sine squared. Well, 1 minus cos squared A is sine squared A, so the top can become sine squared A. And 1 minus sine squared A in the bottom, well, there it is, it becomes cos squared A. So that's using these 2 in blue. This means sine A gets squared and cos A gets squared. Well, if you took sine A over cos A and squared it, that's the same thing. Sine A over cos A all squared is the same as that. Well, sine A over cos A is tan A, so that's just tan squared A. So these 2 get replaced, and identifying sine over cos is tan comes in. So that's simplifying. We'll usually meet them as proofs, which is this: show that the left hand side equals the right hand side. So you take the left hand side and you think of your identities, and the only thing here it can get replaced is 1 minus cos squared A, which is sine squared A. That's all you can do. So there's a replacement. So this is using this rearranged form. Sine squared A means sine A gets squared. Sine A times sine A. So that's what it means. And if you look here, there's a sine in the top to cancel with a sine in the bottom. You get sine over cos, and you've got sine over cos is tan. So that can become tan A, and you've just shown that the left hand side becomes the right hand side. That's a proof. You take the left hand side, use these identities you know to get the right hand side. There'll be half a worksheet practicing these. Another use would be if they tell you a value for sine A. This would be non-calculator. You'd never inverse sine to get the angle doing these, so it's always a non-calculator. Given sine A is 2/3, work out cos A and tan A. I'm going to show you a long method here using identities, and then tell you not to use it, and show you the quick, easy way to do it. So here's using identities, which is a bit cumbersome. Sine A is 2/3. That means 2/3 squared here. That's 4/9. So 2/3 times 2/3. Over here, I'm going to turn that into 9/9, so it goes with the 4/9. Take the 4/9 off the other side, and you've got 5/9. So it's just that 4/9 plus 5/9 makes 9/9. That's what cos A being squared is. So square root that. Square root of 5, square root of 9. You'll get root 5 over 3. But see, this will be plus minus. That's because the angles between 0 and 180. And cosine between 0 and 180 is positive in the first quadrant, 0 to 90. And it's negative in the 90 to 180 quadrant, the second quadrant. So cosine A can be both positive root 5 over 3 in the first quadrant and negative 5 over root 3 in the second quadrant. That's the all sine tan cos used for trig equations. Next, tan A, it's sine A over cos A. Well, you just found out cos A is root 5 over 3, and up here it told you sine A was 2/3. Put them in. Thirds in the top, thirds in the bottom. Multiply top and bottom by 3, and the thirds will disappear, and you'll get 2 over root 5, and it'll be positive and negative because the bottom could have been positive or negative. Now, a long way to do it. This is what we'll do instead. This really practices for higher, because you do this by routine at higher. It's very common. So preparation for higher maths in Scotland is given value for sine A is 2/3. Find cos A and tan A, and what you do is you sketch a right angle triangle, calling the angle A, and that's sine is opposite over hypotenuse, opposite to hypotenuse 3. Missing side in a right angle triangle, you've got two sides, use Pythagoras. This missing side I've called it x, the adjacent is x squared equals 3 squared minus 2 squared, follow it through, x is root 5. Using this triangle, you can use right angle trig to say, well, cos A is adjacent over hypotenuse. That is, it's the root 5 over 3. And for the reason we mentioned earlier, it can be positive or negative because it will be the first or second quadrant between 0 and 180. And the tan A, same business. Tan's opposite over adjacent. Opposite's 2, adjacent's root 5. Again, it can be positive or negative. Now, that is a nuisance to do, and that's really quick, and that's routine at higher. So this is good practice for higher maths in Scotland. Following on from National 5. And again, you would never get asked this at National 5. This is for higher. You couldn't do this except you did it by the method I just showed you with the triangle. Tan A is 2 over root 5. What's sine A and what's cos A? You sketch a right angle triangle, you call the angle A, and that's opposite over adjacent. So opposite 2, adjacent root 5. Missing sides are hypotenuse. So hypotenuse x squared equals root 5 squared plus 2 squared. Root 5 squared is 5, 2 squared is 4, so x squared is 9 and x is 3. So there's a triangle. You can now get sine A because it's opposite over hypotenuse, and you get cos A because it's adjacent over hypotenuse. So there's sine A and there's cos A from the triangle. Where's the plus and minuses? They're not there this time because tan A is positive. And between 0 and 180, the only place tan A is positive is in the first quadrant, 0 to 90. So the angle A is actually between 0 and 90, because from 90 to 180 the tangent's negative. There's no plus minus here. That's a quick way to do these, and that's the way you should do them, and it's good practice if you're going to do higher maths in Scotland. So the worksheet has the Trig identities on it. The kind of questions you just looked at, it's asked here, but it's restricted to between 0 and 90, so you have no problems with a negative answer. They're all positive, it's in the first quadrant. So it just tells you the value of sine A here, and you have to work out cos A and tan A. The answers will be on the sheets. If you click the link in the description, you'll get access to the sheets and it'll have the answers. So they're up as PDFs on the internet. Also, in the second half of this worksheet are some trig proofs. There's no answers to this, you have just to take the left hand side, manipulate it using the identities and get the right hand side. So that's trig identities. As I say, there'll be the exercise on the internet using a link, and answers to the first ones will be there, and then there's a set of notes that covers all the trig equations videos. So all the topics there, including that one there I just mentioned. It's got some examples of proofs. So mostly you'll be using these National 5, these identities, for just very simple short proofs. So hope you find the video useful.